Welcome to a new test and teardown video. This time it's a frequency counter. I think it gotta be a frequency counter, right? But it's a no-name product, or at least it seems like that from the outside. Look at those. It's not 7 segments. It's those special ones where number 1 is located in the middle. So the readout is much more nice. I just got this at the local flea market, and it definitely looks like a homebrew kind of thing, or a kit or something, but the case is definitely made for something like this, a clock or a frequency counter or some sort of a digital readout. I don't see any kind of information about all the switches. We got 4 switches. Those 3 goes left and right. This one goes up and down. This is probably input. And then there's an output or something. Look at that. So this got to be the way in, right? And this is the power supply. Loudspeaker connector from the 80s or something like that, right? Nasty. I haven't powered it up, or I don't know if it works, but I think we should try and open it first because I'm a little bit worried about all this. Yeah, and then what? There's a little plastic locking mechanism. But I think I need to... How do I get this stuff out? That is some weird stuff here. I haven't yet figured that out. Do I push it? No, it's not coming out. So this is glued in. Maybe I pull it that way. Okay, there's a lot of text written here. So it's a kit, not some super homebrew kind of stuff, but still need to figure out how to pull this apart. Oh, so that is funny. Okay, those switches. I don't know exactly what they're doing with the different features yet. But look at that. Something is cut right there, and they're doing something with that signal. It's probably when they enable the Prescaler and maybe some dots and something like that, right? By the way, I googled the name down here. If you see here, there's a name. This Jan is very, very famous in Denmark, actually. He wrote a lot of books and made a lot of electronic building kits, just like this one. And all sorts of articles, and I mean, he was very, very, very big in the old days when I was a kid. I bought many kits and assembled. So yeah, that is a big name. There's a Facebook group assigned more or less to all his projects, and there's also a web page where you can look up this kit. So this kit consists of 2 kits: the main frequency counter, that circuit board, and that circuit board. That is 1 kit. I will put in the link in the description to that web page, so you can see more. You can even download the Gerber files for the circuit boards, and so you can recreate this. However, on that web page, I don't find any schematics. I don't even find a component list, so it's a complete secret what all the different components, the values, the ICs, none of that information exists on that web page. So that is a little bit of a shame. So what else can I say about this this kit? Yeah, the Prescaler here. If you look at that module, the brown module here, that is an OM335. So it's a wideband amplifier. It's a very compact little module here. It is officially rated from 40 megahertz to 800 megahertz, and that is of course in this range where it has its maximum gain. It's also officially rated for 24 volts or 28 volts or something like that. But it says in the datasheet you can just give it 12 volts. This circuit here is running off 12 volts, 9 to 12 volts or something like that, right? At less voltage, you just have a little bit less gain, but it still works. So that is of course the input here. So you can select the front input is probably the fast or the slow one, I don't know that. And then this cable here goes on the back. So this probably goes directly to the amplifier. I think it's a little bit funny. Those two are in parallel, so you can probably just switch this one. So it's using the front. But why are they in parallel? This can't be good for higher frequencies. There's also another funny thing. Look, this one says 1 to 160 megahertz. So of course the first amplifier works way higher than that. But look at the next little thing here. That chip right there. That is an DS8629N. It is a Prescaler chip. 100 divide, fixed divide. It's an ECL TTL circuit. It's got a balanced input, but you can just short one of the inputs to ground or via a capacitor for correct DC balance, and the other one you can feed via a capacitor to the amplifier. And then its TTL output can just go to the other dividers here, and you can probably select different frequency ranges with those different switches. Probably what they're doing here, right? Divide by this and that, extra divide. And the rest of the circuit here, there's actually a little funny thing I want to show you. Maybe I should remove the Prescaler to show you this. Or I could also show you the circuit board layout of that main counter here, because you see all those resistors. This is because we got two 7-segment ICs driving the 6 7 segments. They're driven 2x3 multiplexed. So you always have two of them turned on at the same time, and then it switches between 3 multiplexed sets. I think it's also possible to see here on the schematic that those 3 here, they're more or less in parallel, and then you select 1 2 3 1 2 3 in the multiplexer, and then over here 1 2 3 1 2 3 of these in the multiplexer. So there's always one turned on. I think that is a pretty funny way to multiplex, and this is also why you have 3 selector transistors here. And this is a very cute way to remove flicker, because you see it's not blinking so much when you're multiplexing, because you don't have one that goes all the 6 positions, but you have 2 that's on, and then it goes like that. It's a pretty smart way of multiplexing. And I don't know who invented this, probably this Jan dude. I actually also reinvented this in the Nixie clock designs that I made. And you can find this on nixieclocks.de if you want to see. And but I didn't know. Somebody else invented it before me, really. The 2x3 multiplexing. Yeah, that is absolutely nice to see this was invented before I invented it. Lovely. I think everything here looks quite nice. Could be fun to power it up. There's just only one little tiny thing that I'm missing, and that is a 5-volt regulator or something like that. But I see a lot of C-MOS circuits, so maybe it's just running on a very high voltage. But this one is a 5-volt device, so it's maybe some of those diodes. They could be Zener diodes or something like that. There must be a voltage regulator somewhere, but I don't really find it. Look at those nuts there, really close, or that one close to some of the copper traces. Yeah, let's try and power it up and see how much it blows up. I really hope it works. I think it actually works, or at least it powers up with a lot of zeros. And it's using 0.3 amps at 12 volts. So that is nice. It's really dim. I think my camera here is not helping at all. Yeah, my camera just over-exaggerates this a lot. I mean, this is so dim. Why is my camera picking this up like really bright? That is weird. There's another funny thing about the DC input here. Let me turn on the light so you probably can see this. It says here 9 to 12 volts DC or AC. Isn't that funny? And that is a diode bridge, rectifier bridge. So that means you can't really screw this up. Just power it up no matter what, and it's gonna work. Isn't that just fantastic? This is my special certified things holder. Well, I'm sorry, I can only conclude that no matter how I input here on the front or in the back, I don't get any readings. I tried kilohertz and megahertz and all sorts of hertz you can imagine, and there's no blinkety, no counting, no log of any way. So what I think happened, somebody just has been overdriving the amplifier module. So I think I'm gonna go and measure. Is there something coming out of the amplifier? Is there something coming out of the Prescaler? Is there a way to skip this stage and get into the counter? How is this switching thing working? So I need to go and figure something out. And I'm like really sad that I can't find any kind of documentation. Damn it. So I've just been talking with a lot of these guys. It turns out we have quite a big community here in Denmark about all the good old Jostykit and all those old designs here, and especially Jan Soelberg's design. So he's very famous, and all these guys, I've been in contact with some of them, and I just got the schematics. So I can show you first the schematics for the Prescaler board, and this top add-on Prescaler board. Yeah, it is right. They do call it 1 to 160 megahertz, but the official for the Prescaler chip is 120 megahertz. So I really hope it will go to 160, but we'll see what happens. So the output here is the blue wire, and it turns out one of those switches here is where you select if you want to divide by 100 or 1000. It is explained here on the text. I don't know if you can see that here. So what we can do is we can have a little look. So we can have a little look on the output on my scope. And if you look real careful on the top corner right there, this is 100 kilohertz, and at the moment I input 10 megahertz, but I can switch this little flippity flip here, and now I have 10 kilohertz. So this is a factor of 1000 divide or 100 divide. So this proves the output of the Prescaler is working, right? And I can actually test the entire Prescaler circuit and all that kind of stuff. But of course there is a little problem here with the input. Let me show you again the way that the cable go here, and it goes down to the switch, and there isn't really any termination resistor here, so we need to have the right impedance and all that kind of loading. So I don't expect this to go really high, but let's just try for the interest of this. So this is 10 kilohertz before we have modified anything. I have 100 millivolts input. I can of course crank this up later. So this was 10 megahertz, and then we get 10 kilohertz. All right. So let's just go 20, 50, all the way 100, easy peasy. 100 megahertz in is 100 kilohertz out. So far so good, right? And then 10, 20. So this is the official maximum of the Prescaler chip. Let's just continue a little bit more. That was 160 megahertz. Oh, and here we got problems. That was 170 in, and it's reading 141. So that is also a problem, but I could probably just crank up the... No, that is not the case. I tried to crank up the input level. So back to 160. Okay, 160 in is 160 out divided by 1000. So far so good. That means the 160 is definitely working, but it is a little bit over specified, so to speak. We are overclocking this thing a little bit. Yeah, but the Prescaler board works. Yay! So now I need to find out why the main counter board is not working. Thanks a lot, Carsten, for sending me updated schematics in super nice new rescanned high resolution quality. How nice. And this is the kind of friends I got. They go and find the books, and they do rescans, and they send me, and they help me. Oh man, this is lovely. So here is the main board of the base board, the counter board. And this one is, of course, a nice frequency counter the way it is. And it will do up to 1 megahertz. So input goes in here on via the red wire. I think also via the red capacitor. And then it goes to this little op amp. And this is what I will start to investigate. Is this working or not? Meanwhile, I will show you the schematic so you can see how this is working. And the most important thing to note, that will be those two counters here. This is a 3-digit counter for multiplexed displays. And then you take a 7-segment decoder driver, and then you can handle 3 digits. But of course we got 3 more digits. We got 6 digits, so those two are connected in series, so the output from the first one drives the next one, right? But that one is also multiplexed, so this is why this one drives the other 3 digits. And they're just selected so that they're selected by the same refresh system. And that is why we turn on these and these and these. And then we repeat it again like that. Fantastic, isn't it? So that is how the whole system works. And this is why we can do such a fantastic little counter with that little part count. It's amazing. We should maybe show a tiny little screenshot of a schematic of the previous model. It actually is the same model number, the 18 460 without the C added, the previous version, okay, without this system. Have a look here how many parts you need to do it the good old way without the multiplexed, fantastic integrated parts and all that. There's a huge difference. So I want to show you how I am cheating all the time. I was measuring my input to all the counters and stuff here, because remember, this thing just reads 0, 0, 0 on everything, right? So that means my multiplexers and my 7-segment system, that is working, and this thing is running of the rectified input voltage that is on this capacitor here. But everything else is running off a much lower supply voltage. And of course, when I'm measuring on the op amp, I don't have any voltage. Oops, 0.0 volts is on the op amp. So it turns out that all those ICs down here, they have 0 volts on the supply voltage. And there's a series resistor here and a Zener diode, and then all those ICs on the entire supply voltage net. So how do you figure out where is the short or the disconnect? Why is this not working? Because it can be this Zener diode, it can be an open series resistor, it can be all those ICs and whatnot where there is a short. So what I'm trying to show you here is I take my power supply and I input a very, very low voltage but a high current. At the moment it's 0.3 volts input here on that supply net, and the current is 1.6 amps. So it's only a half a watt I'm putting into that net where there is a short somewhere, right? So what I can do is I can just take my thermal camera and I can look. Okay, the stuff that is hot over here, that is the series resistors for the LED segments, and that is from the previous power on. But right now what we see here is this capacitor here, and this capacitor is on that supply for all that. So I bet that capacitor is shorted. It is that easy to figure out with a thermal camera. And I can do this every time I want to repair something. Just the thermal camera tells me where it is. If I'm, of course, doing the little trick here with heating this up. But the temperature I'm heating up here is so little, you can't possibly check this out with your fingers and such, because it's only a few degrees, right? I think that nailed it. Look at that, it's up and running. I got a little bit of jitter here on the last digit. So there's probably some kind of timing with the resets and the latching. So it's not going for the last digit, but come on, that's all right. This is just how it is. So I just put in a new capacitor like that. I didn't have exactly the right size, but this one will do just fine now. I got all the right voltages and quite a lot of nice and fine sensitivity here on the op amp input. So this trimmer you see here, this moves the trigger point of the op amp so that you will get highest possible sensitivity. So I didn't even touch that. So it should have been 4, 5, 6. Just like that. So this is what I input. Always like to make it nice and visual. Anyway, I think that is what I wanted to show you. Thank you very much for watching. Bye bye.